Okay, good afternoon, everyone. Today I will give a presentation about the specific surface free energy of both ice and Clathrate hydrates. I'm Yu Wei, a PhD student from Civil and Environmental Engineering, and my supervisor is Associate Professor Dr. Nobuo Maeda. And our research purpose is to determine the specific surface free energy of ice and Clathrate hydrate. So that we can get deeper insight on their surface properties like pre-melting like this. Because there's not many researchers studies aspect before so far. And so I think it is significant. And our method is to use a Zisman plot method to obtain the critical surface tension of a solid surface. Let's see these equations. If we write the Young's equations like this, and when the contact angle theta is approaching to 0, and at this time the liquid surface tension will be equal to the critical surface tension denoted as gamma C of a solid, and it is also equal to the difference between the interfacial tension of solid and vapor phase. And the interfacial tension of solid and liquid phase. But the problem is we cannot find a liquid just exactly spread on the solid surface. So what we did is that we find several testing liquid, and if we establish a Zisman plot and we use surface tension as horizontal axis, and we use cosine theta as vertical axis, and we measured the surface tension of testing liquid, and also the cosine theta, and also the contact angle, and then we convert the angle to cosine theta. So we can get many data points like this, and then we did a linear fitting. And the x-axis intercept when cosine theta is equal to 1. So this point is regarded as gamma C. Yeah, that's our methodology. So we choose halobenzene, hydrocarbon, and fluorocarbon, and other testing liquids to characterize the ice and THF hydrate specific surface free energy. So in this table, we measured the surface tension of this testing liquid at 4 Celsius degree by Wimley plate method. It is shown here, these 3 columns. And we also capture the contact angle of a liquid droplet being placed above the solid surface. And we use a software called ImageJ to measure the theta here. And this is the typical testing liquid on ice surface and the THF surface. And we can get, for different types of testing liquid, we can get different Zisman plot. And in this figure, these 2 figures, they are both for ice. This Zisman plot is for benzene substitute. And this Zisman plot is for the fluorocarbon or hydrocarbon. And in this figure, A is benzene substitute, and B is fluorocarbon and hydrocarbon. And from the x-axis intercept, we can get the critical surface tension of these 2 kinds of solid. So our conclusion is that for benzene substitute, ice and THF has gamma C of 30 and 25 millinewton per meter respectively. And for fluorocarbon and hydrocarbons, the value are 17 and 13 millinewton per meter respectively. It's not a big difference. And we can also get that the gamma C of ice is consistent with the literature value is from Adamson's published paper. And we can also say that THF hydrate has slightly lower gamma C due to its higher hydrophobicity. Okay, and then we also analyze our errors. We think they are maybe originate from temperature control or contact angle measuring. And next step, our goal is to measure the gamma C of cyclopentane hydrate.